All right, lesson 1.2. A tip about solving equations. Solving an equation is the reverse of doing arithmetic. So when you do arithmetic, think about the order of operations, where usually you do things like multiply, and oops, it's supposed to be an L, and then you do things like add and subtract. When you're solving an equation, you usually do it backwards. Okay, so thinking about this backwards to get x, instead of multiplying, I would get rid of the addition, and we get rid of addition by subtracting. So on both sides, I want to subtract 4. If I do that on the left side, the 4 minus 4 is a 0, and adding 0 is kind of boring. So I just have a 3x left over here. It's 3x plus nothing. On the other side, I got to finish that. -8 minus 4. So I lost 8. I lost 4 altogether. I lost 12. That seems reasonable. And then to get rid of a multiplication, we divide. Because 3 divided by 3 is 1. 1x is just x. On the other side, we got to divide 2. Negative over a positive is a negative on a good day. 3 goes into 12 4 times.
Yeah.
So I think the answer here is x equals -4. I could have screwed that up. So to check, just plug back into the original. So I'm going to check just to be sure. This is something you should do on a test rather than just pushing a button saying this is my answer. You should make sure it's right. I want to know what is 3 times -4 plus 4. Right? So I'm taking this, dropping it in for x. I think that's the answer though. 3 times -4. -12. So I lost 12, I gained 4 altogether. I think I'm down 8, which matches what the equation says it should be. So I've just confirmed, yeah, -4 is the right answer. Do you have to check? Nope. Do you want to be right? Yeah, then check. Highly recommend it. Do you have to show a check on this worksheet? Not unless I asked for it. And I'm pretty sure on this, I did not ask for it. Just says solved. All right. Another, and again, if you want me to slow down, go back and review something, let me know. Page. So here I have x's on both sides and numbers without x's on both sides. So you just got to decide, do you want the x's to go to the left or do you want them to go to the right? And usually it doesn't matter much. Most people like to take the x's to the left side, so I'm just going to go with that routine. So what should I do first, do you think? Suggestions?
Parentheses.
B has no parentheses.
Oh,
I'm not on
okay.
C yet. Sorry, you're ahead.
Variables.
Yeah, get the variables over. So I'm going to choose to take the 5x over. To do that, I have to subtract a 5x. So that goes away. And I'll have to do that on the other side too. So 5x minus 5x is a 0. 0 plus 15 is still 15. So I just get 15 on the right. On the left, I lost 2 x's, then I lost 5 x's. Altogether, I think I have a loss of 7 x's. And the plus 6 is just hanging out. So since x's went to the left, numbers without x go to the right. So to get rid of a positive 6, I'm going to subtract the 6. And I have to do that on both sides. So plus 6 minus 6 is 0. 0 plus -7x is just -7x. And I don't bother writing down the 0. On the other side, positive 15, lose 6, positive 9. And then almost last step, to get rid of the -7 times, we divide by -7. What's up?
I think you did it wrong.
Uh-oh. What did I do wrong?
So I added 2x to the 5, made 7x.
Oh yeah, you can go, I mentioned earlier, you could go either direction.
But I got a way different answer than you.
Well, let's test it. So on the left side, -7 divided by -7 is 1x. On the other side, I have just 9 over 7, and positive over negative is a negative. Interesting thing about fractions, 9 over -7 is the same as -9 over 7, which is the same as -9 over 7. There's 3 different ways to write a negative fraction. The negative out front, with the top number, or the bottom number, they're all the same thing.
So even if Doesn't matter, it'd be negative either way.
It's negative either way, yeah, as long as one's positive and one's negative. All right, so there's a chance I made a mistake. Anthony and I don't agree on it, so I'm gonna plug back in and double check, because I make mistakes all the time.
No, I see where I'm.
All right, so here there's x's on both sides, so I'm basically gonna draw a line. And on the left, I'm gonna put -2 times -9/7, close parentheses. I mentioned the other day that when you plug in fractions in negative, parentheses are a good idea. And then +6. So all I'm doing is taking this right here, and in place of the x, I'm dropping in what I think it is. In a second, I'm just going to plug that into my calculator. Same thing on the other side. I want to know what is 5 times parentheses -9/7 plus 15. So whip out your calculator. We're hoping this side and that side match. So this is just the check. I don't know if I'm right. Question mark. It's an educated guess at this point. All right, calculator. So -2 times parentheses -9/7, close parentheses, what was it, add 6, yeah, +6. So my calculator thinks the left side should be 8.57-ish. On the right side, we had 5 times -9/7, close parentheses, and then what was it? Plus 15. And the numbers match. So I'm good. I have the right answer. If they didn't match, then either I typed something wrong here, or I have a mistake somewhere in here. Sometimes I get lucky. So again, I found that they did match. If they don't match, either you typed it wrong or there's a mistake somewhere in this stream here. If you don't see it within like 10 seconds, just get a blank piece of paper and try it again, is my advice. Okay. Questions on this one? So again, I think it is worth checking, because otherwise it's just an educated guess and there's plenty of places we could have gone wrong there.
And you said it would be the same if we did it the other way, like we subtracted.
Yeah, let's look at it the other way just to double check. So the original -2x plus 6 is equal to 5x plus 15. Should I copied it right? Yeah. So let's take Anthony's advice and add 2x to both sides. So then the -2x plus 2x cancels, leaving just the 6. On the other side, we're going to get a 7x, and the 15 is just hanging out.
Yeah, where I went wrong is I added 6 instead of minus.
Okay.
But it made 7x equal 21. So,
Got it. Yeah. And yeah, those are the little mistakes I make all the time too. So I want to subtract 15 because it's a positive here. So here I have a gain of positive 16. I have a loss of 15. So altogether that's -9. Color. On the other side, we have 7x. Break multiplication by dividing. So 7/7 is 1. 1x is just x. And there's that same answer I have on the other page, the -9/7.
But you always do the x's, you always try to get the x's on the same side.
Yeah, you want all the x's on one side and all the things without x's on the other
So
side.
it wouldn't make sense to subtract 6 and then subtract 6 from 15.
Right, here we wouldn't subtract the 6 because we brought the x over. So in this case, we want the 15 to go to the other side. Yeah.
pretty much do like whatever's the easier math for you and just put one on one side, one on the other.
Exactly. And often I try to avoid negatives wherever I can, because that's where I commonly make mistakes. Yeah. Yeah. So I think in hindsight, this is probably a better approach. Slightly easier on the negatives, I think. All right, let's try another. Parentheses and other stuff. Ooh, wow, there's a lot going on here. Now, in the other two problems, I just started throwing things from side to side. You should always get each side simple first. And simple just means less ink. So I'm not going to worry about the equation yet. I'm just going to focus on this side here. Oops, stop it. Okay, so on this side, the 4x and the negative 5x are like because they both have x's. So if I have 4x's, then I lose 5x's, then I'm down 1x. And then the plus 5 and the plus 6 are like terms. So 5 and 6 is 11. So there's a plus 11 on this side. And here I wrote it as negative 1x. You could call it negative x if you want. They're the same thing. What's up?
So why did you choose to add the 4x?
Because I'm not worried about solving the equation yet. I just want to simplify each side.
Yeah, well, it's the same.
Yeah, so
why?
Yeah, so
4x? I would minus.
yeah, so another way to think about this, I'm going to rewrite the left side, 4x plus 5. I mentioned the other day that subtracting is the same as adding the opposite of a number. So I could write this as minus 5x plus 6. Addition is cool because it doesn't matter what order you add.
It's negative, so it's an added.
Yeah, so I can reorder these by saying this is 4x plus negative 5x plus 5 plus 6. I'm not trying to move anything from one side to the other yet. Now that I have them next to each other, right, I can see 4x lose 5x's is a negative 1x, 5 and 6 is 11. Right, so we're not doing any kind of opposites yet from one side to the other. We're just making sure each side is as simple as possible. On the other side, remember, whenever there's a minus number on the outside of the parentheses, that whole number and the minus get distributed. So this is going to be negative 3 times x, which is negative 3x, and then negative 3 times negative 4, which is a positive 12. And the 5 is just waiting for something else to happen there. Common mistake here is to try and say 5 minus 3 is 2, but that violates the order of operations because you got to do your multiplication before you can do a subtraction. Next, I have like terms here and here. So the 3x is, the negative 3x is just by itself on that side. 5 and 12 is 17. And I'm just going to think about the equal sign, rewrite that down lower. So again, what's the point? The point is before you start moving things side to side, get each side as cleaned up as possible. Now we can start swapping stuff. I'm going to bring variables to the left. So that means I'm going to take this negative 3x and I'm going to add a 3x to each side. So I lost 1x, I gained 3. Altogether, I have a net 2x left. The plus 11 is still hanging out. On this side, these guys are gone, right? Negative 3x plus 3x is 0. Goodbye. So just the 17 is left on that side. Then we get to move the 11. So I'm going to subtract 11 here and there. 11 minus 11 is a 0, so that's done. So 2x is left on the left. Gain of 17, loss of 11, I think that leaves us 6. All right. Yeah. And then last, to get rid of a multiplication, we divide. So I think x equals 3 is the solution here. That was hard. That was a lot of work. Could I have screwed that up? Yeah, in a dozen different places, so I got to go check. A trick I showed the other day for checking something like this was to use the previous answer button, or you could retype. So let's see, I need to see my calculator and this on a different screen. So what I'm going to do here is I'm going to say, I'm going to take 3, the answer, and just hit enter. And then I'm going to use the previous answer button like it's an X. And then I'm just going to retype just one side of the time. 4x plus 5 minus 5x plus 6, but instead of an X, I'm going to use the answer. So I highly recommend you try this on your calculator. So I've got 4 times, instead of an X, I'm going to use the previous answer. And then I have +5. Then -5 times, instead of x, previous answer, and then +6. So my calculator thinks if x is 3, the left side is 8. The other side had a 5 minus 3 times parentheses x, which is my previous answer. Oh shit. I can't do it that way. The previous answer is not 3 here. So I'm going to have to use 3 for x and then -4. So it only works once, but it's not bad. And the calculator says, yeah, if x is 3, you get 8 on each side. All right, so again, tons of places to make a mistake. Now, on some homework problems, right, you've got that check my answer button, and you can check it if it's right, but it's better you know how to check it without the computer. So I highly recommend at least a calculator check, not writing it out on paper. All right, so this did check out. X equals 3 is the answer. Questions?